Welcome to my third presentation of amines. So in this slide, previously we have studied the preparation of the amine by different method, and also we studied the distinguished test between primary, secondary, tertiary amine by nitrous acid test. Now we are going to study the basicity of the amine. So what is the base? The base is the compound can be explained by taking the three methods. There is the Arrhenius theory, Bronsted-Lowry theory, and the Lewis acid theory. In order to understand the basicity of amine, now we will look into two reactions were written in this slide. In the first reaction, the amine, this is the primary amine, will attach to the alkyl halide, give rise to corresponding your quaternary amine, that is ammonium ion. Okay, so this reaction explains that the pair of electron is donated to the alkyl halide and forms the bond between the N and alkyl group. Okay, N and the alkyl group. This means that the compound or group of atom which donates the pair of electron to the electron deficiency center, that process is that compound is said to be a base. According to Lewis acid concept, the compound which donates or atom which donates the pair of electron to the electron deficiency center, okay, that group said to be a basic in nature. So it donates the pair of electron. By giving the pair of electron, it forms the bond between the another substrate. Okay, formation of the quaternary amine. Okay, so this type of the bond formation is said to be a, this type of the compound are said to be a amines. According to Lewis base, the group or atom which donates the pair of electron to the electron deficiency center forms the bond, covalent bond. That compound are said to be a base. So that is illustrated in this by taking this reaction. Second reaction, the compound which accepts the hydrogen atom according to Bronsted-Lowry concept. So compound which accepts the H plus ion said to be a base. The compound which donates the H plus ion said to be a acid. So here primary amine accepts the proton from the water molecule, forms the nitronium ion, ammonium ion are said to be a base. So these two concepts illustrate what is the base. In generally, base are those, according to Lewis base concept, the base are those which donates the pair of electron. So according to Bronsted-Lowry theory, the compound which accept the H plus ion, that's said to be a base. Okay, so the basicity of the compound can be defined by taking the base dissociation concept. So we know that amines are fairly basic in nature because due to there is a presence of the non-bonding pair of electron, it can donate the pair of electron to the electron deficiency center. So if you look into this reaction, okay, the primary amine donates the pair of electron. When an primary amine added in the water, it accepts the proton from the water molecule, forms the corresponding ammonium ion and hydroxyl ion. Okay, hydroxide ion. So these reactions are is equilibrium. Okay, it can be represented by base dissociation constant is represented by Kb. So Kb dissociation constant is equal to the product of the concentration of the conjugated base and the hydroxide ion by the concentration of the amine and the water molecule. Okay, so the dissociation constant Kb can be written like this. The product of the right hand side is divided by the product of the concentration of the two reactant of the left hand side. Okay, so we know that water molecule is a unity. It is taken here. It is also constant. Kb equal to constant, that is equal to product of the concentration of the ammonium ion and the hydroxide ion divided by concentration of the amine. So it says that the concentration of the basicity of the amine is totally depends upon the dissociation constant. The low higher the value of the dissociation constant and higher is the pKb value, lower is the pKb value, higher is the concentration strength. In other words, the concentration or basicity of the compound is totally dependent upon the stability of the conjugated acid. This is the conjugated acid of amine. Okay, so basicity will be depends upon the stability of the concentration of the your amine. Okay, this is the more is the stable, more is the basicity. Less is the stable, less is the basicity of the compound. So here, in other words, pKb is equal to negative logarithm of Kb. Okay, here the higher the value of the Kb, lower is the pKb value and higher is the basicity of the compound. So this concept is very important in order to understand the basicity of the compound. So we know that generally amines are basic in nature. It easily donates the pair of electron and it easily accepts the H plus ion. So due to that, these amines are act as the basic in nature. Okay. So when the amines are put in the water, it undergo reaction. It abstracts the proton, forms the ammonium radical. So basicity will be depends upon the concentration, stability of the conjugated acid. Okay, stability of the conjugated acid, and also greater the Kb value, lower the pKb value, higher is the basicity strength by this dissociation constant of the amines. Okay. Now coming to the some of the here I am going to take some of the example to illustrate the basicity of the amines. So basicity, we already know that amines are generally basic in nature. The basicity again depends upon the nature of the substituent. Okay, so here I have taken tertiary amine, secondary amine, primary amine and ammonia. So basicity will be increased by tertiary amine is greater base than the secondary amine, in turn greater than the primary amine, in turn greater than the ammonia. So this effect can be the basicity of the this amine can be illustrated by taking these two factors. One is the inductive plus I effect and hyperconjugation effect. What is the inductive plus I effect? So inductive effects are the movement of the electron, displacement of the electron, okay, from lower electronegative atom to the higher electronegative atom is called as the inductive effect. So here in tertiary amine, okay, if you consider this trimethylamine, dimethylamine, methylamine and the ammonia. So here the nitrogen is bonded with the 3-methyl group. Okay, so this 3-methyl group, we know that methyl group is the electron donating group. So here the methyl will donate the electron density across the nitrogen will be increases. We know that basicity will be depends upon the extent of the donation of the lone pair of electron. So if the extension of the lone pair of electron is greater, the basicity will be increases. So due to the 3 methyl groups are bonded to the nitrogen, this methyl group acts as an electron donating group. It donates the electron. The electron at the electron density on the nitrogen will be increases, and the extent of the donation of electron is greater. So because of that reason, this effect is called as the inductive effect. So due to the higher the inductive effect, the basicity will be increases. Okay, in the same cases here, 2 electron donating groups are there. The basicity will be greater than the primary amine and in turn greater than your ammonia radical. The basicity at the gaseous phase is tertiary amine is greater than the secondary amine and greater than the primary amine, greater than the ammonia. What is the hyperconjugation effect? Hyperconjugation effect is the non-bonding effect. It is also called as the non-bonding effect. If any group or atom is bonded with the carbon, that carbon is said to be a alpha carbon. So if the alpha hydrogens are greater, so extent of the electron displacement or donation of the electron is greater. So in the case of the nitrogen, is the extent of the empty pair orbital to the bonding pair of electron, action between the bonding pair of electron towards the empty orbital. This effect is called as hyperconjugation effect. This is increases with increasing the alpha hydrogen atom. Greater the alpha hydrogen atom, greater is the hyperconjugation effect. In the case of the tertiary amine, there is a 9 alpha hydrogen atoms are bonded to the nitrogen. So here greater is the hyperconjugation. Where in the case of the ammonia, there is no hyperconjugation at all, because the hydrogen is the very least electronegative atom. It cannot give the electron to the nitrogen. So because of that reason, this is the lesser hyperconjugation effect compared to the tertiary amine. So the inductive effect plus inductive effect and the hyperconjugation effect tells the basicity of the primary, secondary, tertiary amine. In the case of the gaseous phase, we know that gaseous phase molecules will be scattered each other. Okay, so in that in the most of the competitive exam they will ask, so what happens if the amines, these amines are write the increasing order of the basicity in the case of the gaseous system or a gaseous phase. So that then time you have to follow this this form, the tertiary amine greater than secondary amine, greater than primary amine, greater than ammonia. So coming to the solution state, we know that in the solution state molecules are very close to each other by means of the hydrogen bonding, because hydrogen bondings are greater in the amines, because amines contain the nitrogen is the high electronegativity bonded to the lesser electronegativity hydrogen and forms the hydrogen bonding. So these intermolecular hydrogen bondings are possible in the case of the solution state. The intermolecular hydrogen bonding is not possible in the gaseous phase. So because of that reason, that secondary amine is greater basicity than the primary amine, greater than the tertiary amine, greater than the ammonia. So this effect is called as the solvation effect. Okay, so this when the amines are present in the solution state, the basicity will be represented by secondary amine is greater than primary amine, greater than tertiary amine, greater than ammonium. So you would have asked, sir, here inductive effect and the hyperconjugation effect will not affects? Yes, it affects, because along with that in the solution state the hydrogen bonding and solvation effect as well as the spherical hindrance matters the hydrogen bonding. If the spherical hindrance is greater, energy will be very high. If the energy is very high, the molecule will be unstable. So if the molecule is unstable, conjugated acid will be very less stable. So again, here what happens? The stability will lesser the stability, lesser will the basicity. So in the case of tertiary amine, due to the spherical hindrance and the solvation effect, lesser the hydrogen bonding, what happens? So this molecule is the lesser basic in the solution state, where in the case of gaseous state, the tertiary amine is the greater effect, whereas in the solution state, tertiary amine have the lesser basicity compared to the primary amine, again compared to the secondary amine. So the sequence will be follows like this. Secondary amine is greater base than the primary amine, internal greater base than the tertiary amine, and internal base than the primary amine. So this the basicity of the amines in the solution state can be listed by solvation effect, hydrogen bonding, and the what happened? Another one is the spherical hindrance. This makes the order will be secondary amine greater than the primary amine greater than the tertiary amine. Thank you. Next class we are going to study some of the application, synthetic application of the amine and diazotization. Thank you.